So let's go into power, sample size, and post hoc analysis. So when we're looking at statistical power, that's talking about the probability that our statistical significance test is going to end up giving us a rejection of a false null hypothesis. So if we find that we don't have enough power, we might want to look at increasing our sample size or decreasing our alpha. Remember, your alpha is your affecting that area under the curve where you're looking at what your risk for your model is going to be or your type 1 error. Directionality of your hypothesis affects your power as well. So remember, we're talking about one-tailed tests, two-tailed tests. And so if we have two-tailed tests, that gives me more directions and decreases the power of my analysis. And then also we can look at effect size, which is looking at that estimate of the magnitude of the difference between our proportions that are being studied. And here we have a formula for calculating the effect size for a one-way ANOVA. So when we're looking at determining our sample size, a couple things that we need to look at is we need to look at the smallest effect size that you want to be reasonably certain in detecting. And so if we're looking at our population effect size for a mean difference, you're going to be looking at your population mean 1 minus population mean 2 divided by our population standard deviation. And then you set your desired level of power, which is going to be the probability, once again, that your test is going to detect the effect specified that you're looking for in step 1. It is recommended that you use power about 0.8 unless you have some rationale for a different value. And then we have you enter the values of your effect size and your power into a table in order to determine what your appropriate sample size would be. So remember, when your samples are too small, you end up getting non-significant results, which it will increase your likelihood of a type 2 error. So those effects might not be as obvious. But remember also, if you have too large of a sample size, everything becomes significant. And that also increases your risk of type 1 error. And so when we do post hoc analysis, one that you might want to look at is Tukey's HSD, or honestly significantly different test, where Q is obtained from a table. When you're using an alpha of 0.05, which is pretty standard for post hoc analyses, your Q value is going to be 4.34. And so you're going to look at your variance within divided by the number in your group.